Hi, I'm Juliet Nasser, and I'm going to be presenting Words into Motion, a project I built for my educational technology class at Georgia Tech. The project stemmed from a simple question. How can we use generative AI to help teachers create useful learning visuals in an easy and scalable way? For this project, I decided to focus on elementary math word problems since they pose a challenge for many students and they're a great candidate for visualization. The result is a Google Slides add-on where educators can input a word problem, are shown a storyboard, and can choose to input fully editable AI-generated slides. In the next few minutes, I'll show the learning problem, the design decisions, how the system works, what the evaluation found, and what I'm looking to build next. Word problems are so challenging because they require students to translate real world relationships into mathematical operations. Research on visual scaffolding and multimedia learning suggests that well chosen visuals can support that translation, especially when they focus attention on meaningful relationships instead of decorative detail. But teachers might not have time to build custom sequences for every word problem that they go over in class. That's where Words into Motion comes in. The system was built to show easy to understand slides highlighting the object and relationships, not unnecessary details. That slide sequencing itself supports learning. Rather than showing the entire situation immediately, Words into Motion first introduces the characters and objects, and then it will move on to the relationships and the context. This follows the idea that learners can build mental models in manageable pieces. Also, the students won't jump to try to solve the world problem before thinking about the objects and the relationships. In this example, Maria starts with 5 apples and eats 2. The visual sequence makes the subtraction visible. First, the complete set, then the removed items, then the 3 that remain. The slide designs are intentionally schematic. The goal is to keep attention on quantity and change. Each stage is also on a separate slide, so a teacher can paste the explanation and pause for student reasoning. The solution is built around the teacher. The teacher enters the word problem, the teacher reviews the storyboard, and the teacher chooses to insert the slides and can edit them as they see fit. At that point, the output is made of native Google Slide text and shapes, so the teacher can change wording, colors, object positions, quantities, or even remove or add a slide. This review gate also helps frame the tool appropriately. It's an authoring assistant, not an autonomous instructional decision maker. Looking more behind the scenes, Words into Motion has a couple layers. First, it has the Google Slides sidebar, which collects the teacher's input and provides the preview. Then it also has a Google Apps Script backend that manages the workflow and sends the problem to a language model through Grok. The model does not return finished images. Instead, it returns a structured storyboard in JSON, the operation, characters, objects, quantities, states, answer, and object visual metadata. The app script then takes that data to a small library of drawing routines. Currently, we have apples, books, balls, food, pencils, stars, and generic objects. This intermediate representation was an important design decision because it makes the model responsible for interpretation and sequencing while keeping the final rendering deterministic, inexpensive, and editable. At this point, I'm just going to switch to a quick demo. So for this demo first, we're going to go into Words into Motion and open Words into Motion, and this opens up the sidebar. Now we have our problem. So Maria has 5 apples. She eats 2. How many apples does Maria have left? Okay, then we'll click Generate Storyboard. And over here, you could see a storyboard of what will be shown in each slide. So you can see it has the quantity and the visual for each slide. And then once the teacher reviews this, they can click to insert the slides, at which point it'll input these slides. So we have Maria, we have an apple, and you can see that each slide is fully editable. Let's say I wanted for some reason this apple to be green, I can make the apple green. If I wanted to delete anything or to add a slide in between, that's completely up to me. And at the end, we have this answer slide, which is just showing that the final result is 3 apples. Now for evaluation of the system, because we want to make sure that the answers are correct. I came up with 20 word problems. This included 5 simple addition problems, 5 simple subtraction problems, 4 problems with different action verbs, 4 more complex problems, and 2 examples written in natural classroom language. Within the intended scope, which was just the subtraction and addition problems, the results were strong. All 10 simple addition and subtraction problems had correct storyboards and drawings. Across the full set, storyboard success was 90% and drawing success was 80%. This shows that there was some things that were lost in translation between the storyboard and the drawing. Performance did drop on more complex structures and less predictable wording, especially in the drawing layer. Because the sample is small and there was no classroom studies, these numbers should be treated as a focused prototype evaluation, not evidence of student learning impact. The project taught me that the most useful application of generative AI here is not simply making pictures, it's converting an unstructured word problem into a stage instructional plan, then giving that plan back to the teacher in editable form. The current prototype works best for single step addition and subtraction problems, but it still requires careful teacher review. The next version should broaden the reasoning patterns, expand the native object library, and improve the API key experience. Because right now the teacher has to go in and generate and input their own API key. Most importantly, future work should move beyond technical correctness and study classroom use, whether the tool actually saves preparation time and whether stage slides improve comprehension in the classroom. The opportunity is fast visual scaffolding with teacher judgment deliberately kept in the loop. Thank you for listening, and I hope you enjoyed.